Hi, I'm Daniel. I'm a first-year university student, and I have a crippling fear of unemployment. To cope, I've been watching this show called The Expanse. And there's this really, really cool robot in it with like 6 legs, and it like walks around, and it's like really, really cool. And it like grabs stuff. It's really, really cool. It like cuts open a door. Really, really cool. Yeah, it's really cool, and I really want to build one. And I thought, let's build one. Okay, here's the plan. I want to make a robot that can work autonomously. So that means it should be able to walk autonomously, and it should be able to manipulate objects autonomously. Maybe like a cool robot arm. I want it to be good for my resume, so maybe have some sort of computer vision on the bot. And since I can't add like a super powerful laser to break down doors, it can recycle. Okay, first I'm gonna need to figure out how motors work. I actually have no idea how anything works as a part. How do I spend the least amount of money possible to figure out? Well, first we need hexapod. That means a good motor will start with bad motor. Coordinate all your motors to work in sync. Additionally, the robot arm it needs to pick up water. It also needs to have it's not very nice how electronics like a robot would actually that would have to be iterated. I don't actually know how any of this works. I didn't have any engineering courses in my engineering program first term. And the only thing I learned was like linear algebra and there's like matrices or something. I want to transpose a matrix. Oh, I mean, how hard could it be? Okay, quick disclaimer. I will be using Make Your Pet's cheapo hexapod design just for the legs. Only because I will be using cheap Amazon MG996R motors, I believe. And some even from AliExpress. And those motors aren't exactly known for reliability. I don't really want to spend too much time experimenting with different leg designs, so I will be using his legs. However, everything else I will be doing on my own. So for example, the frame, the robot arm, and everything to house the electronics, I will be doing. So yeah, enjoy the montage. So 4 months later, Handy is working perfectly. Zero issues, no bugs, works just as intended, works just like in the TV show. So yeah, let's show you how it works. So here's Handy. He's a sex-like hexapod with a robot arm. I think it's 1, 2, 3, 4, something, 5, 6. I don't know. It's a lot of degrees of freedom. Each leg is 3 motors, so that's 18 motors for just the legs, and then there's like 6 more motors on the arm. It was a lot of motors, and I used really cheap ones from Amazon, so that caused some problems, which I'll talk about later. If we want to look at the inside, so inside Handy, we have a 5600 milliamp hour battery, I'm pretty sure, at 7.4 volts. Oh, this is kind of hard to see. A step-down converter right here, so it can power the Raspberry Pi 0 to W, as well as having enough voltage to actually power all the motors. Each side of the hexapod is controlled by a PCA 9685 motor controller, and the one on the left actually has enough left to control the robot arm as well. In terms of wire management, I actually did used to have these like wire sleeves, but I don't know, something about like bending the cables or something. A lot of the motors just wouldn't work if I put it in the sleeve, but like if I take it out and I like bend the cable a bit, the motor starts working. So that's some like black magic electricity happening. But yeah, it's pretty cool. So I have a Python code that does all the inverse kinematic calculations and sends angles out as an output, and I have C++ firmware on the Raspberry Pi 02W. I couldn't afford an actual Raspberry Pi, so all the video processing and the computer vision is actually done remotely on my laptop. To start Handy, all we have to do is start the Python script, and in a remote terminal we can SSH into Handy's Raspberry Pi, and all we have to do is run the Python program. This causes Handy to go into his default state. This is just for testing. Honestly, this messed up so much more stuff than I actually had to. Now with the Python script running, all we have to do is connect to the Raspberry Pi's address, and Handy can stand. Woo! I have some key bindings to make him do stuff. So you can turn the other way. And now mainly, my main issue, which I still can't solve, is walking forward causes him to deviate from the path. And obviously that's not optimal if I want to make him autonomous. That's mainly the reason why he's not autonomous. The computer vision does work though. There's a camera at the front of his claw, and if we press start camera, we actually do have a camera, and it works real time. And the object detection actually does work. If I have a water bottle, like this one, normally it'd be empty. If I put it in front of Handy, it will detect it, and it'll be able to know exactly where it is. And originally the plan was for it to automatically pathfind towards the water bottle, and actually pick it up, right? But obviously the deviation in the walking forward makes this kind of a hard task to do. Which I guess like you can still do that manually, but it's kind of cool if you do it manually. And you kind of can just line it up like this, and then down. So obviously there are some kinks. Mainly I think the walking forward problem. One, due to the fact that I use some really cheap servo motors, and some of them are from Amazon and the other ones are from AliExpress and some are from Temu. So maybe they just don't perform the same. Or two, I'm just an idiot and I calibrated them wrong. Which I don't think is too likely considering how, I mean, look how cool it looks, right? And it can stand and it can turn properly. So probably not that. That's my little Handy adventure over the past 4 months. I'll leave my GitHub in the description, maybe, if I clean up the code enough. A lot of 1 a.m. coding there. I'll leave it there. I don't think it's the code problem. I'm pretty sure it's all hardware problems. As for future plans for Handy, I don't think I'm gonna be working on him too much, considering how if I were to work on him, it'd just be replacing all the motors with more expensive ones, which I don't have the money for. And again, thanks to Make Your Pet for all the STL files. Those were really helpful.